everybody. Welcome to Climate Chat with me. I'm Clara. I work at Pearlstone. And today we're going to talk about Maryland's climate, what it's going to look like in the coming years, and what we can do about it as things are changing quite a bit. So here we go. This is Pearlstone. Miss it a lot, but it'll be there waiting for us. So this information is coming from a conference that I went to with one of my coworkers, Joe Murray, in late January. And the title of the presentation of this conference was Adaptation Planning Practices for Water Supply, Reservoir, Forest and Piedmont, Coastal Plain, and Central Appalachian Areas. So that's quite a mouthful, but what it essentially is saying is what kinds of strategies can we use as Maryland's climate is changing, specifically in the central area. And this information was provided by the Northern Institute of Applied Climate Science, NIACS, and it was sponsored by several organizations, including the U.S. Forest Service and USDA. And in the room with us were government agencies, private consulting firms, people who were actually foresters, and this was what they did. And we also had university professors who were providing a lot of the research that this presentation is based on. And it happened in North Point State Park. If you've never been before, go check it out. It's really lovely. So to give a brief overview, Maryland has 3 different geographical areas. In the east, there's the coastal plains and Piedmont area. In the west, there's the mountainous region, and in the center is the Piedmont region. And that red star on the screen on the map shows where Pearlstone is located. So it's smack dab in the Piedmont region. And Piedmont, for those who don't know, means foothills. And in this case, we are at the foothills of the Appalachian Mountain. And why this is important is because each geographical area will have different types of changes in their ecosystems, because their ecosystems are different. The mountains look a lot different than what's happening down in the bay. So when they do this research, it is pretty specific. And many of these much of the information is based on climate models. So the model that they were using is called ATMOS, and it breaks down the current century, the 21st century, into 3 30-year time periods. And these models are measuring annual and seasonal changes in precipitation. And the goal of these models is to model possible futures so that we can better prepare ourselves as the climate is changing. These do account for certain levels of uncertainty. They try to take in as many constraints and limitations as they can when they create these models. However, they can't necessarily get all the variables right. So they are models. They're not fact, but they're based off of a lot of evidence and a lot of research. So these are some of the best things that we can go off of as to how to make our decisions for the future. So some basics are, in this specific model, they look at different variables like temperature or precipitation based on 2 scenarios. One is a low emission scenario and a high emission scenario. So that means for a low emission scenario, that means there's a minimum change from a baseline temperature and precipitation. When this baseline was created, is the baseline for this research is 1990s temperature and precipitation rates. And for the high emission scenario, it's a maximum change. So that means the most change from 1990. And more specifically, a low emission scenario happens when we switch over our energy sector to renewables and we cut down emissions from agriculture, transportation, industry, and we start building greener buildings, and we change the way our life looks drastically. And a high emission scenario is basically business as usual. So if we continue to rely a lot on fossil fuels, and so on and so forth, that's basically what we're doing now. We're going to continue to go on the path of a high emission scenario. However, this global pandemic is certainly changing things up. There's been a lot of research based on showing that there's reduced rates of air pollution. There's animals who are coming into spaces they haven't been in a long time because humans aren't there anymore. And we've seen lower levels of greenhouse gases like nitrous oxide in the atmosphere. So, like, we can drastically change our behavior. It's possible. This time we didn't have much of a choice, but we can potentially shift ourselves to a low emission scenario going on in the future. So this is one of the basic graphics. Also, if you have any questions, feel free just to pop right in and ask them, put them in the chat. I'll be throwing a lot of information at you. So this graphic is talking about the projected changes in annual temperature for this region. So that includes the Central Maryland region, the Piedmont region, and the coastal plains. It's not including the western part of Maryland. It also, as you can see, includes Pennsylvania, parts of New York, New Jersey, and Delaware. So the left column, PCMB1, is the low emission scenario, and the right column, GFDL-A1FI, excuse me, is the high emission scenario. So as you can see, in both scenarios, our temperature is expected to increase. But in the low emission scenario, it's projected by the end of the century, it's projected to increase by 2.2 degrees Celsius. And why that matters is, according to scientists around the world, they've been telling us not to exceed a certain point called a tipping point, which means after that point in time, we'd start to see cataclysmic changes in our climate that might not necessarily be reversible or mitigatable. So that means we'd have to adapt more. So a 2.2 increase in Fahrenheit is actually less than 1.5 degrees in Celsius, which is under the 2 degrees Celsius standard that scientists have been saying will be the tipping point. So in a low emission scenario, we can actually really mitigate climate change and drastically prevent really and big changes to our climate. In a high emission scenario, that's different. So by the end of the century, we'd be seeing an increase in 7.6 degrees Fahrenheit. And in the mid-century, we'd be seeing an increase of 5.2 degrees Fahrenheit. And that translates to 2.8 degrees Celsius, which is past the tipping point. So by mid-century, if we don't change our behavior, we could be seeing really cataclysmic changes. So that's in our lifetime. That's in our, like the next generation's lifetime. So it's really a question of which way are we going to go? We maybe could go straight down the middle, but we're going to be learning more, and as we experience it ourselves and as more research comes out and as we start making, as a society, decisions to change our behavior. So with this increasing temperature, even in a low emission scenario, we're still going to be seeing an increase in temperature. Sorry, one moment. All right, so even in a low emissions scenario, we'll be seeing changes. One of these changes is extreme temperature. So in a high emission scenario, we'll be seeing both very hot days and very cold days, which will affect all aspects of life. Agriculture, industry, our very lives. If it's very hot outside, there's a lot of people who are very vulnerable to high temperatures. There's a lot of people who are very vulnerable to low temperatures, including people with illnesses, people who are experiencing homelessness, people who are elderly, children. A lot of people are vulnerable. We're also expected to see shorter winters. So because of the increase in temperature, we're going to see less snowfall. And they expect to see, at least in a high emission scenario, 3 to 12 less centimeters of snow by the end of the century. And why that matters is because when we have snow, it melts and it starts trickling down into our reservoirs, underground waterways, and aquifers, that's the word, and kind of helps keep our water table full and plentiful for the rest of the year. If we don't have enough snow, then it won't necessarily trickle down. We might see it in bigger storms where it doesn't necessarily trickle down to the soil. It could also affect roots and affect decomposition processes. And as a result, we're probably going to see more rain too, because instead of it being snow, it's going to turn into rain. We're also, interestingly enough, going to see a longer growing season. So as temperatures are warmer, plants can start to leaf out earlier in the season and continue to leaf out farther into the season. By the end of the century, scientists have projected that we're going to have 1 or 2 more months of the growing season, which is a big game changer for the agriculture industry. We'll be seeing an increase in biomass, and it actually produces somewhat of a feedback loop where more biomass is more photosynthesizing, taking in carbon dioxide, storing it in their body in the form of leaves, wood, roots, putting it into the soil. So we might be taking in some of that CO2 that we're putting out in the form of pollution from fossil fuels, but it's still it might not necessarily balance out. And because of shorter winters and extreme changes, that could definitely affect crops. We're also expected to see changes in tree composition or forest composition. So our forests are a mixture of northern boreal forests and southern species, like the southern red oak. So as temperatures increase, more northern or colder acclimated trees will no longer be able to live in the abundance that they have in this climate. They're going to migrate northward, and trees that grow very comfortably south below us are going to start migrating up into our ecosystems. So while that might not necessarily seem that drastic, it does change the way that our ecosystems run and habitats. And we could be seeing changes in how insects are impacted but are interacting with the ecosystem. Maybe diseases might come through, like for trees. And it doesn't necessarily consider the impact of fire. So we might see actually lag times between when the northern plants, the northern trees recede up northward, and then between when they recede up to the north and when we see more southern species coming in from the south. So it could potentially be a place where invasive species can be introduced. As you guys might have already noticed, we're going to be seeing more extreme weather events. So more ice storms, more heat waves, and more droughts. These events are really difficult to model because they're so specific and so ever-changing. But they're going to be more frequent and more severe, and that will definitely affect all walks of life. We also might see an increased probability of wildfires because of the increasing temperatures. Forests, especially also if we have different types of, if we have more rain at certain points of the year, but not at other points of the year, if we're experiencing droughts, the forests that we have might not necessarily be the most resilient. Or in addition, forests might shift to more fire-associated species like oak and pine because they're more resistant to wildfires. So I just threw a lot of information at you. Does anybody have any thoughts, questions, concerns? Or maybe what does this bring up for you? Or how might this affect your own life? That's okay. I can let you ponder. So, what are we going to do about it? Well, luckily for us, there are many solutions. There are many possible avenues that which we can start to tackle this new climate that we will be living in. And one of the coolest ways is actually forests. Forests sequester carbon dioxide through photosynthesizing. And like I said, they turn that carbon dioxide into biomass, into the leaves, the roots, the wood itself. And U.S. forests actually absorb 15% of carbon dioxide emissions that are produced from fossil fuels. So our forests are a huge key to how we are going to manage our life in the future. And some people, especially, I think one scientist, Jim Voss, he was a speaker at the conference. He called forests as they were a kind of green infrastructure. They were organisms that we could partner with to mitigate climate change. Who knew? And in addition to being beautiful, they actually provide a lot for us. So, what can we do for our forests? One of them is actually thinning out trees, thinning out the forest area, and that prevents overgrowth and it allows a forest to be multi-aged. So that means for a forest that at different stages they can sequester carbon at different parts of their life, and it preserves the forest as a whole. And allows it to withstand a lot more changes in its climate, and especially with temperature rising and soil composition and tree composition changing. In addition, we can actually remove invasive vines and plants that are competing with trees, allowing them to grow bigger, more fuller, allowing them to take in more carbon dioxide and produce oxygen. We can also actually perform prescribed burns in meadows and forest areas. And the reason why that's important is, especially if we're going to have droughts, this is something that California has seen a lot, is they have, as we have more droughts, we might have drier plants, drier leaves, twigs, things of that nature. That's perfect tinder for a wildfire. And by doing a prescribed burn where it's in a controlled environment where firefighters who are specifically trained for this job can detect when is the perfect time to set a section of a piece of land on fire. And it takes out the dry brush, it takes out invasive plants that might be there, and allows more native species to re-enter into that land. And it can also increase carbon intake into the soil. So it's actually a really useful tool for trying to have our forests and have our meadows be healthier. In addition, we can help support the growth of drought and fire-resistant trees, as those are likely the trees that are going to be in our forests in the future. So either plant them yourself or thin out things that are competing with it. Of course, make sure that they're appropriate for your climate, your shifting climate. And of course, plant trees. The more biomass we have, the more plants we have in our ecosystem, the more carbon dioxide they can put in, the more they can sequester into their bodies and into the earth. And the more that we can do to try to mitigate and try to change what's going to be happening for our future. So my question to you guys is, now that a lot of us are working at home, or maybe our work lives are different, even societally our lives are different, what can we do to mitigate climate change from our own homes? And not just necessarily how it relates to trees, but what are some things that we can do at home? Please feel free to write your responses in the chat. Like, for example, work from home. Yeah, that's a very good response. People are not driving their cars as much, which means all the pollution that's coming from our cars is is not happening. Oh, wow. One person responded that their roommate created a great sign to put on their trash can to help them to remember to compost. Yeah, composting is a really great way. Some of the one of the highest proportions of carbon emissions that we produce in our daily lives is actually from our food waste, because the entire process that it takes to get to get to our tables is actually really carbon costly. So we don't want to let this go into a landfill. We want to put it back into the earth, put it back into the cycle. We have some other responses. Be a vegan, be a freegan. Think about your food choices. A lot of carbon emissions and methane emissions come from the agricultural industry, particularly related to animal products. Buy local and carpool with your friends. If you're still going to work and if that's still a possibility, even if it's not a possibility now, if we need to stay distance, maybe in the future. Great. And we have be mindful of energy consumption in your house. Absolutely. If you notice you're leaving lights on, turn them off. If you have a chance to look at your energy bill, consider trying to switch to solar instead of using maybe nuclear powered, like power that's coming from a nuclear power plant, or coal or natural gas. And that's a really good way. Yeah. Alrighty. Well, thank you everybody for joining us. This was a pleasure, and I hope you get to take away either information. Oh, someone said hang dry your clothes. Also very great. Less electricity, helps everybody out. I hope that you learned something. I hope that you can take something away that is meaningful, and at the very least, knowing what's going to happen in the future or possible futures just allows you to be more prepared. And when it comes to maybe voting or things that are happening on the local level, you can be more informed about what the actions or the decisions that are being voted on might change for the future. Oh, we have a couple more responses. Somebody suggests gardening, solar heaters, and calling your representatives from your home. That's super important. If you care about climate change and you care about how our planet is changing drastically, not just for us, but for future generations, please let your representatives know they do care, they do take note, and you could totally potentially change their minds on some stuff. Also partner with local organizations that are doing work. In Baltimore, there's the Food and Water Watch, there's the Black Church Food Security Network, there is Blue Water Baltimore. There's tons of organizations that are doing work around climate change, even if they're not explicitly doing stuff about climate change. And of course, vote and tell your friends to vote, get registered, allow yourself to participate in the process of decision making. All right. Thank you, everybody. It was a pleasure. Enjoy Earth Day. Get outside, soak up that sun, and just tell Mother Earth that, dang, we love you. Bye, everybody.